Alright, this is the practice quiz for acids, bases, and neutralization. I made a mistake. It's going to be 4 sections, not just 3. The 4th section is going to be some vocabulary dealing with acid-base definitions and some definitions about titration. So the first 3 sections were mentioned before: pH calculations, titration calculations, and then acid nomenclature. On the practice quiz, notice there are some comments. Go ahead and highlight for the comments. So pH can be solved by doing 14 minus POH, or negative the log of the hydronium ion concentration. Move away a little bit. POH can be solved by taking 14 and subtracting pH. It can also be solved by taking negative the log of the hydroxide ion concentration. The hydronium ion concentration can be solved 2 ways: 10 raised to the negative pH, or take the Kw, 1 times 10 to the negative 14, and divide by the hydroxide ion concentration. The hydroxide ion concentration can be solved 2 ways: 10 to the negative POH, or Kw, 1 times 10 to the negative 14, divided by the hydronium ion concentration. Those comments will be pulled on the actual quiz. Up here, instead, you'll have useful equations. You can get all of that information from these things. You just have to do some manipulation. When it comes time to actually solve, because it's a Google Sheet, you can go ahead and work the equation out. 14 minus, and I can click on the cell with pH, and that'll give me POH. With the hydronium ion concentration, one of the options was to do 10 raised to the negative pH. And while I should take 1 step when possible, or 2 steps when possible, I shouldn't take 3. So I should go ahead and do 10 raised to the negative POH. For this one, that would be 2 steps, or take 1 times 10 to the negative 14 divided by the hydronium ion concentration. That as well would be 2 steps. Notice you're going to get 13 total points from each of these. Now as I delete them, you can see that one was worth 6, this one was worth 4, and this one was only worth 3. It depends on how much work you have to put in. Just don't forget to do all 3 of them in each of the rows. The next one, we're going to consult the M1 V1 N1 equals M2 V2 N2. I would have written MA VA NA equals MB VB NB, but there wasn't a way to make a nice fancy subscripted A or B. You have 2 of those problems. Remember, you're going to know everything there is to know about the titrant. So the titrant for us, it typically is the base. So I can go ahead and just start adding the base to both tops. The base is easily identified on these because it has hydroxide. The analyte is going to be the acid in both of these cases. That is the thing I know the least about. It's the thing I only know 2 things about. And so I am solving for the 3rd thing about that acid. As you'll notice, this is a little improved from the classwork. It actually counts up my score as I go. Now remember, you know all 3 things about the titrant, so I'm going to know the molarity, I'm going to know the volume, and because of the identity, I'll know the number of moles of hydroxide that'll come off of it. When I read through the problem to figure out what I'm solving for the analyte, this one shows me I'm solving for the concentration, which means I must know the volume, and again, because of the identity, the number of moles. You can see again it's adding up the score. I can then go ahead and look for all the matching things and find out. I can go ahead and put in the molarity of this one, and I can even maybe cheat it a little bit. I have to be careful. There is a limited range that I'm allowed to have before it goes ahead and marks it wrong. Now, the number of moles. Remember, you're supposed to count the number of hydroxides and the number of hydrogens that you see. So when I look at this formula, I see one OH group, and down here I see one hydrogen group. Remember, this is dimensional analysis, so you can multiply across the top. Again, using Google Sheets as your calculator rather than getting out a new calculator. And dividing by the product of the bottom, which is why I'm using parentheses again. Now, let's say I mess this up. I'm off by a decimal place. The answer is now going to turn orange because it shows that I followed the math even though this was flawed. I'm not going to do number 6. You can go ahead and do that. This video is already getting a little bit long. With acid nomenclature, you need to know the polyatomic ions. You also should have a periodic table available for the 6 elements that are in the nonmetal section that might get used here. Now, if you end up with duplicates, count it as a gift. Remember, with the acid naming, when we find a polyatomic ion that has an 8 or ite ending, the 8s, like this is chromate, the 8s become ic acids. We find that this was acetate, it becomes acetic acid. This one does not have any oxygen involved. It also doesn't end with ite or ate. This was cyanide. Now, cyanide is going to be when it's with hydrogen like this, it is going to be a hydra acid. So those get that hydro prefix, and then the ending, usually the ide, just becomes ic acid. The last one, we've got oxalate. The 8s become ic, and we add acid. Down below, these are going to move around. Please carefully read them, especially on the practice quiz versus the real quiz. A hydronium ion producer was Arrhenius. A hydroxide ion producer was Arrhenius. For the acid, a proton donor was Brunstens-Lowry. The proton acceptor was Brunstens-Lowry. The electron pair acceptor was Lewis for the acid, and the electron pair donor was Lewis for the base. The chemical in the reaction vessel to begin with that is being analyzed, that would be the analyte. The pH point between acidic and basic that shows that there's just enough of each for a complete neutralization, that's the equivalence point. Some people made some mistakes on their lab with that. And the chemical in the burette that is added to the chemical in the reaction vessel, the flask or beaker, etc., would be the titrant.